This is section 2.2 on piecewise functions.
Hi everyone, so we're going to be discussing what a piecewise function actually is. So it's a function whose graphs are formed by piecing together graphs of two or more functions, which sounds like a mouthful. But what's going to happen is you're going to take bits and pieces of different graphs and put them together to form one graph. But you might have different domains for each of the functions that we talk about. As far as your very important concepts go, we have function notation, which is going to be written as this. So f of x is equal to this bracket. And we have function number 1, function number 2, function number 3, which could be like equations of lines. So you might have like a y equals mx plus b, but here's our y. So we would just have 3x plus 4, 7x plus 2, might just be a number 4. And each of the domains that go along with that piece of the function. So it's important to draw an imaginary line to separate the different functions at the domains. It kind of gives us which side of the equation that we actually need, and you'll see that as we go through for an example. So for example 1, it says graph the piecewise function and state the domain and range. So this is the graph, we did it out for you, of a piecewise function, but how do we get there? So notice our function notation says f of x is equal to, and we have our bracket. Now we have x plus 4. And this part is our domain, that x is less than or equal to 0. We have 3 as my other function, number 2, that x is greater than or just greater than 0. So notice that there is a black dotted line at x equals 0. That's because of my domain right here. So I want to separate things at 0. It's important to say, okay, what values are we working with to separate these different functions? So the first equation, x plus 4, is really kind of like y equals mx plus b. So my b value is 4, so I start at 4, and then you continue graphing. So you would go up 1, over 1, up 1, over 1, up 1, over 1. And you would have a line that would continue, and this red would continue down to the green. You'd go in the other direction. But now the domain comes into play when you determine what part of this function do you actually want. Well, if x is less than 0, I want everything to the left-hand side of my restriction. So I want everything to the left-hand side, so I'm going to erase anything to the right, because I don't need it. I need everything to the left-hand side of that. And that's my first equation. Then I would graph my second one. Well, y equals 3. Your slope is 0. If you have something y equals some number, that happens to be a horizontal line. So the horizontal line is at 3. So if you graph 3, it goes on forever in this direction and on forever in this direction. But my domain tells me that x has to be greater than 0. So if x is greater than 0, I want to use an open circle at 0, and I want everything to the right-hand side of my restriction. So I erase everything to my left. Now, when I talk about my domain, I'm looking for all my x values and all my y values. Or excuse me, for domain, it's all my x values. Range, we'll talk about all our y values. So for domain, I want to see, okay, what is my leftmost value? Well, since this arrow goes on forever, my leftmost value is negative infinity. As I'm going to the right, I notice that I do have an open circle here and a closed circle there. So at 0, I still have some value. They're both not open circles, so because it kind of fills in that hole, that I do have a value at 0, and I continue to move to positive infinity. So my domain is from negative infinity to positive infinity for this particular graph. For the range, I want to talk about my y values. So you start at your lowest most y value, and you work your way upwards. So again, this arrow continues down to negative infinity, so that's where I start, and I'm going up, 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 up. And the highest value that I have is right here at 4. So because it's a closed circle, or it was a closed circle before I drew over it, that because it's a closed circle, 4 is included. Now another piece of this question might be to evaluate f of 2. Well, f of 2, I can either look at the graph and say, okay, f of 2, what is my y value? Or I can also use my information with this function. So f of 2 is like the same as f of x, where x is 2. So is 2 less than or equal to 0? No. Is 2 greater than 0? Yes. So I want to use this function. So f of 2, I only have one answer. I can't substitute an x. So your answer is simply 3. And again, that would have been confirmed on the graph. F of 2 up to 3. So f of 2 equals 3. For our next example, we have a couple pieces of this graph. Notice that there are 3 separate graphs to this one piecewise function. So you have to graph the piecewise function and state the domain and range. Here's my function notation. I have x plus 5 for x being less than negative 3, 2x between x is between negative 3 and 2, and x minus 4 when x is greater than or equal to 2. So right away I want to draw in my restrictions. So I have ones at negative 3 because that's one of my domain restrictions, and another at 2. So I drew another one at 2. For my first graph, I have x plus 5, which again is in the form y equals mx plus b. So we graph this equation. You start at 5. 1, 2, 3, 4, 5. And from here you would go up 1, over 1, up 1, over 1, up 1, over 1. And you would have what looks like this line. But I want every value to less than negative 3. So that's to the left of my restriction imaginary line. So I'm going to erase everything up until that point. For my second equation, I want it between negative 3 and 2. So that's going to be in this middle section of 2x. Well, again, y equals mx plus b. Not y equals mx plus 5, but y equals mx plus b. My b is 0, so it passes through the origin. I go up 2 over 1, up 2 over 1, down 2, back 1, down 2, back 1, and so on and so forth. And you can continue that as well. But if I want it to be between negative 3 and 2, you want to erase everything outside of negative 3 and 2. And lastly, you have x minus 4. So you would start down at negative 4, and you would go up 1 over 1, up 1 over 1, and you would have this line here. But I want x being greater than or equal to 2, so here's my x equals 2. I want it to be greater than that, so that's to the right-hand side. And let me erase everything to the left-hand side. So now when I talk about my domain, I'm looking for values that go along my x-axis. So this arrow goes on forever in that direction, so I'm going from negative infinity, and yes, I have a break here, but I still have a value because it's closed in here. And then I continue on throughout these values, and again I have another break, but I have a value at 2, so I keep going until positive infinity, because this graph goes on forever to positive infinity. When I talk about my range, what's my lowest y value? Well, my lowest y value is negative infinity, and my highest y value, again, there's no breaks in this graph this way, is going to be positive infinity. When it says to evaluate an f of negative 5, well, negative 5 falls into negative 5 is less than negative 3. Well, that's true. So you would say negative 5 plus 5, because you're substituting in that value for x into the first part of your equation. It's not true for either one of these, so I want to make sure that I use it for that first part. And that is equal to 0. If I'm talking about f of 2, well, 2 is mentioned here and here, but if it's equal to 2, I want to use my last equation, which would then be 2 minus 4 is equal to negative 2. So f of 2 equals negative 2, and that would be evaluating.